Hello, everyone, and welcome to our webinar, LLMs in Banking, Predictive Analytics for Financial Services. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars, 2 per week, demoing data and AI use cases, new tools, new technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or any ideas on topics that you'd like to see in our future sessions. Speaking of future sessions, we've got another great session coming up in just 2 days. So on Wednesday, we will be presenting how to protect data in a FinServ RAG pipeline, relevant to today's topic, kind of. So you can come and join us to see a live demo on how to implement RBAC. That's role-based. What is that again, Akmal? Role-based. What's RBAC stand for?
Role-based access control, Matt.
That's it. Thank you.
Yeah.
Role-based access control and data tokenization in your financial services LLM apps without losing that data context. So if this topic sounds interesting to you, go ahead and RSVP right now. I put the little short link there on the screen. I'll put that in the chat in a minute. You could also take a photo or a screenshot of that QR code that's on your screen. And I hope to see you on Wednesday. All right, let's get back to today's topic. You are welcome to participate in today's discussion throughout the session using the Zoom and Q&A functionality at the bottom of your console. It's just a little button. We've got a lot of registrants today, but we have an internal mission statement to follow up with every single question that comes in, even if that means some via email. So go ahead and ask away throughout the session. We'll try to get to as many as we can during. Make sure that you include your name and email address when you're asking questions. We will not be answering anonymous questions. We'd also love for you to try out today's technology. In fact, anyone who tries it today will be entered for a chance to win either brand new AirPods Pros or Meta's new Ray-Ban LLM smart glasses. We've got a new prize here. So it's going to be your choice, whichever you prefer here. If you've got one or the other, you can choose the other one. But all you need to do is visit that link that's on your screen. It's the MySQL.co LLMs banking raffle. I'll put that link in the chat in a minute as well, or you can take a photo or a screenshot of that QR code. It's very simple. You may know that we've had a free trial for several years, but just recently we've also introduced a completely free shared tier. So that you can play around with SingleStore indefinitely without a payment commitment. So just log into that link. We'll get that link out into the chat in just a few minutes, and you will be entered for today's raffle. Let me introduce our speaker for today. Akmal is a senior technical evangelist at SingleStore. He has strong expertise in big data, machine learning, and AI. He is a prolific author and regular speaker at our webinars on data and AI. Highly recommend you Google him, check out his blog on Medium. He's got some awesome content. Akmal, welcome. The floor is yours.
Great. Well, thank you very much, Matt. And thank you all for joining today, wherever you are. Good morning, good afternoon, good evening. I picked up just a couple of posts already in the Q&A there, Matt. So Andrew was asking the question, can anyone hear him? I hope so. Often the problem for us on the panel is that we forget to unmute. So hopefully you can hear me okay. And this link here that Matt mentioned, actually, I'll show you where this leads to and what you can get in just a moment. Okay, so we'll take a look at that momentarily. All right, so there we go. Oh, one thing I ought to add. Notice something very interesting here. Our new logo. There we go. So I just I think I'm missing that in the slides, but that is our new SingleStore logo. You might see the old one in a few places here and there as well. So that will get changed in time. Okay. Now, given the subject that we're discussing today and the kind of importance that the weight that it carries, I thought it very relevant to put this disclaimer out there. Okay, so let me just read that. It's quite short, but it's very important. So, using LLMs in lending decisions raises ethical and regulatory challenges, including potential bias in model outputs and a lack of transparency in decision making. It's crucial to work closely with legal and compliance teams to ensure that your predictive analytics approach adheres to all relevant laws and regulations, such as fair lending laws and data privacy regulations. Additionally, consider fairness and bias mitigation techniques to ensure equitable lending practices. You'll actually see a little bit of this later on in terms of the bias potentially and the model, kind of out of our control sometimes. And that is why I put this here, simply because there may be certain legal requirements depending upon where you are. And therefore, you have to adhere to those requirements. So very important to make that disclaimer upfront. Okay, so there we go. My presentation in terms of slides is very short. I haven't got too many, but I would like to cover a couple of points. And so once we've done that, we'll look into an example, okay, which is kind of loan approval prediction. If you're in financial services, I mean, it's one of the things that certainly in terms of retail kind of customers, people like me, for example, and you probably, you want to get a loan for some purchase. Maybe that's a small loan or something larger, perhaps for a car, or something even larger, maybe, for a home that you're buying, a flat or a house. And therefore, we'll take a look at some aspects of that. So we'll look at some traditional techniques and some tools that I came across and some packages that I kind of really liked, because I felt that they really did a good job giving some insights. And then we'll look specifically at the application of LangChain and how natural language, for example, is relevant. And then we can ask it and pose some questions to it and see what its response is. And then why it is a little bit, be cautious, I would say. Okay, we'll look at that momentarily. So essentially, we'll talk a little bit about loan data, how we can manage this with SingleStore. Actually, very easy. We'll build a loan prediction model, a couple of technologies that we'll look at. Okay, but you may have come across that. And then Chat and Lime, which are these packages that I came across, which I thought were pretty good. They seem to be fairly well baked. And if you are working with these kind of traditional machine learning sort of technologies, I think they will fit in really well. And then we'll look at LangChain, okay, and see how well that compares to the existing techniques and why you need to be a little bit cautious about it. Okay, so just 2 slides about SingleStore. So this is a kind of a nice one in terms of showing the timeline. Okay, so we start all the way over here. So it feels like we're working for a startup. It's kind of 100 miles per hour every day, all the time. But there we go. 2011 is when we started. And in terms of what's happened, you can see some interesting kind of inflection points here. So around about between, roughly middle of 2017, the revenue really started to increase significantly. And then round about the middle of 2019, you can see, again, the number of customers started to increase significantly. And so we have quite a significant amount in funding, and we are $100 million plus in annual recurring revenue. Okay, so and over 350 customers as well. Okay, so you can see that the company has been around, the technology is mature, quite a few things have been done over the years, and the next slide essentially kind of captures that we have this notion of universal storage. Okay, so it's a product that can handle both OLTP and OLAP, and I believe there's a patent for this technology as well. Other vendors have announced similar sorts of things, but we've actually got something that's delivered. It's being used by customers today. Okay, so it's working and available right now. We can work very well with lots of other technologies as well, such as Kafka, for example. And if you're a regular, you know that I've used that in the past. One of the last webinars that I did, we looked at Spark, for example, and fraud detection. But we can also access things like, S3 buckets, or work with Hadoop, HDFS. And this animation here is really showing the kind of ingest at scale using this concept of pipelines. Okay, we're not using that today, but it is something that we do cover fairly regularly in our webinars. We happily work with all 3 cloud providers in the Western world. Okay, AWS, Google Cloud, Microsoft Azure. And today I will be using AWS. Okay, and I'll show you a little bit of that in a moment. We can run on-prem, and momentarily I'll show you where in the portal, okay, once you've signed up, if you haven't done so, there is on the left-hand navigation pane a section that you can go to where you can get a license that will allow you to install a 4-node cluster in the cloud, on-prem, wherever you want. You've got sufficient resources, and that's free of charge, okay? The only limitation with the product is simply the number of nodes. Other than that, it is fully featured, and we do have customers actually using it in that way today. It is multi-modeled, okay? So not only is it a database system now, of course, we've been supporting relational for quite some time, but geospatial, full text search, time series. Okay, let me just highlight that there. We do have the Lucene full text search engine built in as well. And the other thing is vectors. On the previous slide, actually, it shows that vectors were added in 2017. So it's not something we just added recently, although we have improved upon the offering. Okay, so we have a specific vector type now. We can do ANN indexing as well. Lots of other cool stuff there. We've covered that in previous webinars as well. Okay, so just to finish off then, real-time decisions, AI apps, dynamic experiences, machine learning, which is what we're going to look at today. And you can happily use this with your favorite dashboard technology. There's JDBC, ODBC support, for example. And I tend to use Metabase, the free version. This is just a jar file, download it, and within like 2-3 minutes, you can be creating pie charts, bar charts, and so on. You know, you can connect to SingleStore very easily indeed. Also, worth adding that the notebooks, we have a Jupyter kind of like environment built in now into the portal. Okay, and I'll be using that today to do some demos for you. And if you're familiar with Matplotlib, Plotly, Plotly Express, these kind of technologies, or whatever else you may want to use in terms of creating visualizations, it's very easy to do, okay? I'll be using, I think, Seaborn today to do some heat maps. Okay, so rather important in terms of Gen AI's impact in banking. This is from a report published by McKinsey. So you can see that enormous potential. I mean, 300 billion in additional value in banking and financial services from Gen AI and its impact in that domain. And some of the areas that they've identified as being, you know, those where the biggest impact will occur on the left-hand side here. Okay, let me just highlight that. So we've got the customer operations and support, marketing, software engineering, risk and legal. Maybe not the kind of traditional things we might have thought of, perhaps. Okay, well, our focus is slightly on the user, much more so than those might suggest. But as you can see, lots of potential in many, many different areas here. And certainly in all of these, you know, in terms of business requirement, we can see that banking is right up there. Okay. So some of the ways that you can do machine learning with SingleStore, this is not an exhaustive list, by the way. Okay, just some examples. So we have looked at Spark very recently, and I'm actually working on a series of articles on Spark and SingleStore. Expect more of that in the near future. And I think we have a dedicated Spark webinar in the pipeline, hopefully next month sometime. I think we'll just schedule that. Notebooks, SingleStore, okay, plus ML libraries, scikit-learn, you know, whatever your favorite packages are. We have the vector functions, okay? So there's direct support for Euclidean distance, dot product, and very easy to use cosine similarity as well. It's in the documentation. Actually, I just published an article just over the weekend demonstrating how you can create your own function for cosine similarity, okay? Just using some existing SQL syntax that we support. Something else here worth noting and could be useful to you is this thing here. There is this code engine using WebAssembly. Okay, so this is built into the product, and this is very useful. So if you've got, for example, let's say some Rust or C++ code, you can convert that into UDFs. These can be loaded into the product. These will run in their own space, okay? So in the event that there's some bug in the code there, they do not bring the entire engine down, okay? They run in a sort of protected space, And that can be very useful to extend the capabilities of the system. So there, the specific example you can see, I mentioned there, something called VADA, which is Valence-Aware Dictionary and Sentiment Reasoner. It's something that I've used for sentiment analysis previously, and it's a great way to, utilize some existing packages that other people have written, and then just be able to write some code around that, upload that into SingleStore, and then straight away, as far as the database system is concerned, it treats it just as a UDF. Okay, very useful. And then last but not least, OpenAI. We are going to use that indirectly today, okay, through LangChain. All right. So loan approval prediction. A couple of things then. Why would we be interested in using LLMs? Well, here's a few arguments that I think we could put forward. Analyze large quantities of data from a variety of sources. They are very good at doing that. So things like credit reports, income statements, spending habits, they can analyze that and summarize that very quickly for us. They can look for patterns and trends. Customer who has a history of making on-time payments on other loans and has a stable job, for example, could be done. I appreciate, financial institutions already have systems in place that can probably do that. But I think that with LLMs, we may be able to garner additional insights and make more informed loan approval decisions. Now, here it starts to get a little bit tricky, okay? So it says here, can consider more information such as social media data. Use with care, okay? So I'm a little bit cautious about that. You end up in all sorts of murky water if you start to think about what people are posting online and use that as the basis for whether you're going to give them a loan or not. There's issues around laws and regulations and all sorts of things there. I mentioned it purely because it's something that I came across, but I'm like I said, I'm a little bit dubious about its application in the real world, or used with extreme care. Where could we use it for loan approval? So develop predictive scoring models, score loan applications based on their likelihood of repaying a loan. So we look at a little bit of data today, and yes and no. It could be useful. I think my personal view is that traditional techniques currently work better, simply because if you think about the way that LLMs work, they're great at kind of text analysis, right? So that might be great if you want to analyze emails, for example, or reports or PDF documents or things like this. That is what they're very good at analyzing and summarizing. I know we're kind of moving into other realms as well in terms of voice and video and images as well. In fact, Matt has got me down to do a webinar in a few weeks' time where we're looking at how we can manage video data with SingleStore, for example, and that could be really useful. And breaking the video down into individual frames, for example, and then storing the embeddings in SingleStore and analyzing that. And I've been working with Clip from OpenAI to do that. It's awesome stuff. So we'll be doing that very shortly. And then identifying fraudulent loan applications. Well, fraud I covered in a previous webinar very recently. And my kind of take on that was that actually I was disappointed, simply because what I'm trying to do is actually bend the technology to try and solve a problem, which I think it wasn't really designed to do. And so the results didn't come out as good as they could have done, possibly. And again, traditional ML techniques seem to score much, much better. So what I think this could do is be kind of an augmentation rather than a replacement. That's where I see the benefits of this. And then ultimately, improve the customer experience, provide customers with personalized recommendations for loan products and services. That could be a very useful area as well. Although, again, we do have technology that allows us to do that, but I think that LLMs could improve upon that. The challenges then, well, they're complex and expensive to develop and deploy, and not all of us have the resources of OpenAI or Google or Meta or Microsoft. These corporations have lots of resources, lots of talent, and lots of money to be able to build these large language models. And for the rest of us, it could be very, very difficult. We don't have the time or the effort or the money. There's all sorts of problems around that. So we need to think carefully about that. And I think a very important question that needs still to be answered is this issue of bias. They can be biased, which can lead to inaccurate predictions. And I think that's very, very important, especially in this particular area where we need to be very careful about what is the kind of process. And if you like, if we try to work back from the way that a decision has been made to see what the other parts of that workflow. How did it arrive at that decision? Those can be very tricky, I think, at the moment. The explanations may be a bit opaque, or largely opaque and difficult in terms of finding the basis for that. And of course, require a lot of data to train. Again, difficult and expensive, especially for small and medium-sized businesses. So for those kind of organizations, I think generally you will tend to look at the outside world for both commercial and open source offerings. And I think that you could, of course, still build your own. I mean, that's possible, and that could be very specific to your environment, might be very specific to your domain, and you keep it to yourselves. That's entirely possible. It is built internally for internal use. Okay, so with that said, let's move on. Okay, and let me just work on the demos here. The key things that I used, the three sort of key third-party technologies, was a little bit of scikit-learn, okay, logistic regression, because I'm going to look at loan approval and see what we could do there in terms of getting some data and then being able to make some predictions for that. So again, logistic regression. So this is kind of like the fraud detection example that I used not too long ago. There's only two possible outcomes, right? Either you get a loan or you don't get a loan. And then I looked at BERT, Chap, and Lime. Okay, BERT, not very useful. I think, again, I'm trying to bend it to my will, try to use it for something. There's lots of models out there that you could use. I picked one particular one, and again, you'll see the result momentarily. And then this LangChain SQL agent, okay, as a way to kind of interrogate SQL database, SingleStore, with some natural language, and then provide some context around that in terms of the prompt, and ask it to calculate something for me and come to a decision. And we'll see that as well. Okay, so let me just switch now across here. Okay, and one thing actually that I might try and do, just that, okay, let's just zoom in a little bit. I think that it works across all of these tabs, and that's the third one. Okay, let's just make sure we've got all of these set up so that we can view them. There we go. All right, so this first one here, okay, so this is a sign-up page that the link that Matt shared with you. So as you can see, Matt already mentioned this, okay? Here, start free with our shared tier, if I can speak correctly. There we go. This one. Okay, I'll show you that in just a moment. The second one here is, yes, the $600 credits. So if you want something a bit more than the shared tier, this is the way to go. And that's quite usable. I've had credits since literally almost the time that I joined over 2.5 years ago. I've still got credits today. So if you manage the resources carefully, that can be really useful. So as you can see on the right-hand side, you've got a couple of ways that you can sign up, and literally it's like a minute of your time, okay? So once you've done that and it's verified and you're in, this is what it will look like, okay? Roughly. I may have some slight differences from what you may see, but essentially you've got this left nav. Okay, let me just get my box here on this side here. Okay, which has got a bunch of controls. I'll walk you through those in just a moment. And as I mentioned before, so right down at the bottom, all right, let me just blow this up here. If you have a look, you'll see that there's this thing called self-managed licenses. All right, if you can see that, let me highlight that for you. There we go. And obviously I won't click that, so I'll reveal the free license, but that's where you get the license, where you can go away and just install your own 4-node cluster wherever you want. Okay, so that's perfectly possible. But the cloud-based environment is a great way to start. Up here, you can see it says here group. Okay, this is one way. So you click on that. There we go. And then it gives me a couple of options here. So to create the workspace. So in order to do anything, if you want to use notebooks, you've got to create a workspace. Okay, need some compute resources to be able to run. You cannot just have the notebook environment by itself. So this is the starter workspace, as you can see. And you can modify this, okay? So you can change the workspace name here. Currently, it's set to starter workspace 7. I could change that if I wish Currently, only AWS is the cloud provider. And we have one region. Hopefully this will change in the not too distant future. Okay, other options will be available as well. And then as you can see right down the bottom here, your database name is already entered, but again, you can modify that to whatever you want. And as long as that database doesn't exist, i.e. somebody else is not using the same name, it will create that for you. Because remember, this is a shared environment, okay? And so once you've just a couple of things that you might want to just change there, just click on this. Okay, there we go. And there we are. It's literally 1 second. It's provisioned the compute resources, okay? You've got your database there, and you're ready to go. And here you've got the kind of connection details, okay? So if you want to connect through, say, a CLI client or a SQL IDE, it will, let me just clear these arrows here. So there you can see, I mean, it's showing you my password. Don't worry, it's okay. I'm going to remove that anyway. But I'll just say create user. That's fine. And then here you can see it provides details for the host. Okay. The port number, in this case, 3333. And I am that username. There's my password. And there's my database. Okay. Now, one thing to remember is that because this is a shared environment, if you want to connect to this, you will need a PEM file, and you can download that from here. Okay, and just show you that this link here that will give you the certificate that you need. And once you do that, you can just get in very easily. Okay, so I did that recently with a CLI client, which is actually running in a separate space. But part of this is that it is a shared environment that's already running. Okay, and you are just provisioning some resources on here for yourself, and that's why it's fast. On the other hand, okay, and let me get rid of this. Okay, so I'll drop this because I really don't need this at the moment, but just to show you. And then the other option here, as you can see, again, if we go back to group, okay, there we are. You see the standard option here, which again gives you the ability, more configuration options. Again, you can change the group name there. You can choose your cloud provider, for example. I'll stick with AWS. You can choose the region, for example. In my case, probably something physically closer, like London, would be better, and so on. There's a couple of options, again, that you might see that are unique to my environment, but that's okay. Generally, you'll see pretty much the same thing. And then just say next here. And then here, you've got the option to, again, change the workspace name. How much power do you actually need? I mean, what is the size of the environment you need? So at a minimum, S00, 2 virtual CPUs, 16 gigabytes of RAM, and that eats up a 0.28, okay, burns through 0.28 credits per hour. So careful management of that, and that can last you a long time. And again, if you need even more compute power, you can configure something even bigger if you want. Okay, there we go. All right, there we go. And then all you need to do is just say create workspace. Okay, I won't do that, okay, because I already have something running. So let me just go back, okay, and then go back. There we are. So that second option does take a few minutes because it has to provision the resources specific to what parameters you've specified rather than using the shared workspace, okay? So I've got some compute resources already running here. And then here, what I'm going to use today is this, again, on the left nav, you've got notebooks. Okay. Just show you that. There we go. If you click on this, you have the option to create some, and you can have a blank one or create some from some templates here if you wish. Cancel that. And then if I just select this, you can see that up in the top right-hand corner here, where it says new notebook, I can actually choose to import something from file here. Okay, it's one of the options there. Okay, so Matt will give you a link to the notebook that I'm going to use today, a little bit later on, as part of the follow-up email. And so you will have a chance to upload that. And let me just show you the notebook. So here it is. Okay, so this is what I've been working on. And let's just walk through this, okay? Keep an eye on the time. So so we are sort of half past the hour. That's fine. All right, then, here we go. So I'll walk through this with you, okay? And then show you what I've done and then what sort of results I've obtained. So building predictive analytics for loan approvals. So standard sort of setup. LangChain, Lime, OpenAI, Pandas, all these libraries, Seaborn as well, and so on. Okay, fairly standard stuff there. And then just getting my matplotlib, NumPy, Pandas, etc. Imported there. And I'm using scikit-learn, and we're just loading some data here. So this data is a file that sits on a Google Drive. I think it's actually my Google Drive, and I have made that publicly available. So you can download this, and this will work fine. In the event that you're prompted that you'll get it, right. So there's two firewalls, okay? One of the firewalls sits specific to the notebook environment. Again, try to keep the bad guys out. There is another firewall for the workspace and the group and the compute resources as well, okay? That's fine. But here, you may get prompted if you're trying to access something externally. You'll get a little pop-up telling you that you need to add this, whatever the URL is, the fully qualified domain name to the firewall. And once you do that, you'll find it'll work fine, okay? So in case you see that previously you had to do this by hand, but the engineering team have very graciously added a pop-up now, which actually walks you through and tells you that there's something that has to be added to the firewall in order to allow the external access. So it's just getting this CSV file, and here we are. If we take a look at this, okay, so this is quite a small file. I struggled to find appropriate loan data. Very, very difficult to find something meaningful. I don't work in the financial industry, well, not today anyway. And so, I had to search around looking for other places where I could get some data that I could utilize for this kind of problem. And so here we've just got 5 rows here. So in terms of the data, well, we have some information about gender, okay? Whether you're married or not, your marital status here, okay? Your dependents, your education, whether you're self-employed, what's your income? If you have a co-applicant, what's their income? What's the loan amount? How much you want to borrow? And here you can see that we've actually got some missing data as well, okay? So we need to do something about that. The term of the loan, how long it is, credit history, okay, whether you have one or you don't have one, where is the place that you're living in terms of the property area, where is it urban, semi-urban, so on. And then the actual loan status, okay, did that person get the loan or not? And so it's Y for yes and N for no, okay? And so if we take a look, you can see that here we've got overall, I mean, it's about 598, you can see, although there is some missing data here, okay? Not everything is up to that level. Here, it's 577. Let me use my arrow there instead, okay? And here we've got 549. So clearly there are some missing data from there. And the easiest thing to do, the quickest way to remove those is just drop incomplete rows. And that's all I've done there. Okay, that's all this code does. There we go. In place equals true. Get rid of them. You could impute. I mean, I'm sure if you're a data scientist, you'll have the appropriate techniques that you can use. And then once we've done that, again, we can take a look at that. Well, it's reduced the number down to 505 now. So as you can see, very small data set that we are working with. And sometimes when you're working at that scale, the model that you build obviously is entirely dependent upon the quality of the data that you have. A larger data set would be a lot better, and then some way to be able to decide how much of that you want to use. We just do a little bit of cleanup, get rid of the loan ID column there. And the thing that we are trying to calculate here is the loan status here. Okay, so we get rid of that from in terms of the separating the features and the target variable. Okay, so we drop that from the features, and then that is the target that we are trying to aim for. First thing we can do is just a visualization. Let's take a look. Let's take a look at the data and see what we can see in terms of, and notice that this is SNS heat map correlation, okay, numeric only. We are just looking at the numeric values rather than the other values, which we'll get to in a moment. So these are a number of dependents, application income, so on and so on. No real surprises there. You can see that the loan amount comes out quite strongly in terms of its correlation with the actual income of the applicant. So, the fact that you've got income shows that you could probably afford that loan, and therefore how much you want to borrow is strongly determined by how much you are earning as a general rule, I guess. And again, we can take a look at the amounts of the loan, what it is that you want to borrow. Well, generally, again, we can see that the amounts are fairly small. I think these are measured in US dollars. So the vast majority of these values here sit somewhere between $0 and $2,000. Okay, they are very much clustered around there. And we haven't really got any very, very seriously large amount, except for a few outliers here. I mean, that's about 8,000. That's about maybe 6,500 roughly, and so on. And again, we can take a look in terms of some of the other ways that we could have a look in terms of the numerical features. Okay, these are pair plots. So again, just taking a look at some of these things, see if there's anything in particular that catches our eye. I didn't see anything that really caught my particular attention. It seems to follow a similar sort of pattern to what we've just seen above. As far as the distribution is concerned. All seems good. Okay, so next thing to do, just take care of these categorical columns such as gender, married, dependents, education, self-employed, property area, and so on. A bit of feature engineering here. So just using one hot encoding. And then the other thing is that with one hot encoding, as you know, you can opt to say, either it is or it isn't, either 1 or a 0. It's sort of binary, right? But the thing is, sometimes you have multiple values. So for example, let's say you have dependents, okay? Now that could be 0, 1, 2, 3, or more, okay? So in that case, we should try to keep all of those values because they might have some bearing upon the loan itself. So this thing here, drop first equals false. So we keep everything. And then we just simply build a model, okay? Do a bit of model training there using scikit-learn, okay? And then we take a look at the importance of the features. No real surprises there. Credit history seems to be a very strong indicator. Okay, where you live, semi-urban seems to be rather a strong indicator there. Married, whether you're married or not, and there seems to be stronger emphasis on the fact that you're married. It's greater weight to that. And one thing that surprised me when I first saw this was gender. I would have thought it didn't matter. Apparently it does. Gender seems to be an important consideration there. Okay, again, more about that shortly. Just make some predictions then, and then we take one particular value out of the set of predictions here. So this is looking at one specific entry. Okay, so out of all the values that we have. So, and here you can see the reason why we keep all of those values from one hot encoding, because we've got 0 dependents, we've got 1 dependent, we've got 2, and then 3 or more. Okay. And then as you can see, we've got several different types of property. We've got the rural, okay? We've got semi-urban, and we've got urban, okay? So it's kind of important that we keep all of those just in case they have some kind of bearing upon the actual loan. Okay, then take a look at BERT here. So BERT, bidirectional encoder representations from transformers, something that I think that was released by Google some time ago. A natural language processing model built upon the transformer architecture represents a significant advancement in understanding and processing human language. I think there's a whole bunch of these. The one that I particularly used was this thing called DistillBERT. Let me try and see if I can highlight that for you. There we go. And then I was curious to see how useful this was. So I took a phrase which is quite well known in Western culture. I mean, the quick brown fox jumped over the lazy dog here, okay? And you can see their mask is that I wanted to see whether it was smart enough to actually fill in the correct value there for this particular sentence, which I thought, well, it might have heard of it, should have done, it's well known. And so when it generated the actual value for that, well, I didn't quite get the right value. Okay, so it's given me the quick brown fox jumped over the quick brown dog jumped over the lazy dog. So grammatically, you can see it's correct, but it's not the value I expected. How useful this is, I don't know. I mean, I think a bit more investigation there in terms of utilization. And then finally, what I did was to bring all of this together, utilize this kind of library, BERT, and take the model that's already been built earlier and then combine the two to see, could I make use of these two technologies together and then provide a summary of taking this particular value here. What is the applicant? Okay. Happens to be Mr. Blobby. And then they have this income that we've pulled out. We've got credit history details that we've pulled out, the loan amount, okay, and the property area. And again, utilizing that with BERT, basically ask the system, come to a conclusion. Tell us, would this person be approved or denied a loan? And so here we can see the summary. So in this particular case, just comparing this, I think, let me try and get my box here. I think that's going to be a lot better here. So it's just given me a summary and used a little bit of BERT there in order to retrieve the property area. And in this particular case, it's given me the model prediction is that, yes, loan approval decision is approved based upon that information. And actually, this is correct, okay? Because comparing this to what's actually in the data, remember we have the column on the extreme right-hand side, which actually tells you whether someone was approved for a loan or not. Well, this actually matches that correctly. It made a correct decision in this case. If we take a look at what are the kind of factors that were important to it in terms of making this decision, you can see, obviously, credit history comes out quite highly there. The income, let's have a look. The name itself, probably because, if we take a look at this, it's male, all right? It is the title there is Mr., which again, the system kind of takes to be that it is male. All right. Fine. That's great. Now, how about if we want to get a little bit more deeper in terms of explanation? Well, this technology, Shapley additive explanation, rooted in cooperative game theory, provides a systematic approach to explaining the output of machine learning models. And this I found very, very useful because I was able to take my model and then again, taking the top 10 kind of features of the things that influenced that model and then how it arrived the way it did. And there you can see a summary of it. I've got a visualization of this momentarily as well. Okay. That's in no particular order, by the way. It's not meant to be in some kind of order here. It is in the kind of a particular order in terms of the things that are important. So again, you can see credit history, no surprises there. We would probably expect that. That's quite important. Again, your marital status seems to have some relevance here. Where you live seems to be quite important. And again, the gender, again, seems to be very, quite important there. And then as we work down the list, you can see that things that become much less sort of relevant, whether you're education, whether you're self-employed, if you have no dependents or if you've got 3 or more dependents, doesn't seem to be a strong influencer in this case. Although if you do have one dependent, it does seem to be something that influences the overall decision there. There's this thing called a force plot we can, again, generate similar, just the same data, just a different way to see it. Okay. Sorry about the text there. It's a little bit messed up. I think that's doing a bit of JavaScript there. Not bad in a Python notebook, but it's more or less the same thing. Okay, just a different way to see the data. You can see the things that have a higher impact upon it versus those that have a lower impact on it. And then finally, this thing here, LIME, local interpretable model agnostic explanation, machine learning technique designed to provide understandable explanations for individual predictions. Okay, and this is why it's important. So basically, you take one of those rows from the prediction and then try to get more insights into that to see what it is that has helped to drive that decision. How has it come out the way it has? And if we take a look at that, again, you can see here in terms of the prediction probabilities, some things are kind of rather important. Okay, so the loan amount, the property, the dependence, whether it's greater than whether it's 1, okay? And so on. So this is, again, providing much more personalized prediction, if I can put it that way, in the sense that we're able to look at individual people here and then sort of see what are the things that have kind of influenced the model the way it has. And that can be very, very useful. Again, quite surprised at how useful this is in order to drill down Obviously, these things have limitations, okay, so be aware of that. I mean, they aren't perfect by any means, but I think great if you're working with these kind of traditional machine learning techniques. So overall, how did we do? What sort of results did we get in terms of the model itself? Well, we didn't do too badly. Most of the loan approvals I actually got right. Okay, a couple of them we got wrong here, as you can see. And then up here, you can see we fared much less better, you know, in terms of the refusals. So those were what, half of those, 22 of these type 2 errors. So that is probably going to annoy some customers. But sorry, type 1 errors, type 2 errors here, that it was actually a yes, but predicted as a no. So, you know, overall, not bad. We didn't do too badly, okay? So just to clarify, I'm just trying to find something. This one, I think I may have missaid that, is a type 1, type 2 error. Actual was no, but we said yes. That's wrong. That's a more serious error. Whereas just below here, it's yes. It should have been, but we said no. So we would have annoyed some customers there, right? So that's, but the most serious problem, we got a higher value there, all right? Okay, so overall, just some metrics there. Not too bad for a first attempt, for a first pass, but again, the quantity of data, the quality of the data, again, I think had a significant bearing on this. If you have access to better data, again, you can try this out in your own time. And so that's taking some bit of AI, if you like, utilizing a bit of BERT there. How useful was it? Not very. Would I do it again? No. I think that Lime and Shap did an awesome job. Traditional sort of machine learning techniques work really well in that case. And then here, what I tried to do was to use LangChain for the similar sort of thing, okay? So just creating the tables, okay? That's the database. Just uploading the 2 data frames, okay, with our training and test data into a loans train and loans test tables within that database. I've just input my OpenAI key there, import the libraries there. Okay, set up the LangChain environment here. Very straightforward to do. I struggled with this, and I was complaining to Matt a little bit earlier on about how these libraries and packages should change all the time. OpenAI and LangChain are notorious for this. Not to take away anything from how awesome these packages are, but you have to stay on your feet and you have to stay on your toes. You really need to keep up to date with the changes that come, because sometimes these break existing code. It's my fault too for not pinning down specific versions of these libraries, but that's okay. I mean, you know, it's a lesson learned. And then here, what I'm essentially doing is then saying, okay, let me use this agent and then ask through LangChain, make this inquiry of the database system. And so the prompt I've created is, I've told it, use the loan trains table to build a loan approval model, okay? And then because it can go off and use an enormous number of tokens and essentially just give me, an error, not even a warning, it would be an error because it's just over the limit. It would just stop working. I had to limit it here to 3 rows of the table. I'm giving it a very restricted quantity of data to look at, simply to keep within my limits. And then I'm just saying to it, once you've built the model, determining if the following loan would be approved. And here I'm providing it with similar sort of data that I did earlier, okay? So the gender is male, the application income is the same, the credit history value is the same, the loan amount is the same, the property area is the same, okay? And then I'm just saying that limit your reply to either approved or denied. Tell me what you think. Would this person be given a loan? And then I haven't told it anything else about the structure of the data, that the fact that there might be a column on the end, for example, that contains values. Okay, in the loans train table, I think that's missing anyway. Okay, because remember, it's the train and test data. It is contained in the test data. Okay, that's a separate table. But here, I've switched this verbose mode to true, just up here. Okay, so that I can see how LangChain actually evaluates this. And then here it gives me a sort of detailed breakdown. So it says, okay, first thing I need to do is to look at the structure of the table, and it does that, and it goes away, and that is actually correct. And then it says, okay, I'm going to look at some rows now, and it does that. And then it formulates a query, and then it says, okay, let me look at what these values have been given. And it's interesting because what it's done is for this the data that I entered in earlier, it's picked up the gender, the applicant income, the credit history, the loan amount, the property area, and it's decided that, yes, this person would be approved. And it's finished the chain, and then the output is, yep, this loan is approved. Okay. Now, to test this a little bit further, I said, okay, rather than just using the loans test table, let me ask you to do something on some data that you haven't seen before. And so take a look at this and take this gender female. Okay. Just again, there we go. And applicant income is 5,000. Credit history, well, they don't have one. The loan amount, quite small, only $103, I think there, and they live in this semi-urban area. And then just, again, apply this same process to this. So if we just go back up here, you can see here, okay, so let me just get this, okay, so again, this is loans train, okay? So in the first case, that data already exists. All of this is actually in that table. And I've simply asked it, go away and build a model, and it's been able to find that, and it's come to some conclusion, and it's given me the output to say, yep, that person will be approved. In this second case, you can see, again, I'm using this, okay, loans train table, same set of instructions, but now I've given it something that it hasn't seen before. These values do not exist in that table. And so it's gone away, and it's tried to do this. Again, it's looked at the structure of the table. It's tried to pull some values back, and then it's, as you can see, here is the kind of the unique bit in terms of it needs a bit of analysis to see. This didn't occur last time simply because now it's dealing with something it hasn't seen before, and it's verified that the query is correct, and so on and so on, and eventually it comes to the decision denied. Okay, so this person will be denied. And actually, if I check that value in the test table, okay, where this actually exists, that is correct. So in these two cases, in a sense, it's made, yeah, I mean, of course, it's made the correct decision in both of these cases. It's given me some insights into how it's arrived at that decision. But as you can see, all of this just relates to the database, the schema, the values there. I don't get any further information as to how it's actually derived that decision. Can you see that? Whereas with traditional machine learning techniques, we may be able to drill down a little bit further. Here, I think if you attended the fraud detection webinar that I did, there are actually some things that we could have done, which I didn't have time to do, but we could investigate a little bit further about what OpenAI is actually sending us back and look at those values. There's kind of logs that we could check to see that. Here, I'm not sure if there's an equivalent. So this is magic, okay? It's awesome. It makes the right decision, but how reproducible is this? And how would I know that it's not introduced some bias into how it's made that decision? These are kind of critical things that I think still largely remain unanswered. I don't have a great answer for you there in terms of that. So yes, I think it could be used, but I would urge caution, okay? That's my feeling here. Okay, now, one final thing here, just before we go back to the slides and take some questions, is that I use this technology called MindsDB for loan approval. So MindsDB, you could think of like as an AutoML. It works really well with SingleStore. And so all I did was I fed it the same data here, okay, and walk through the process, again, create the model, show me the predictions, create a predictor. It's all awesome. It's kind of like SQL-like syntax. And then just get some information about the status as it's deciding what to do. Show me the structure of the data, okay, and then make a prediction. Okay, so it's done that down here. You can see the actual versus predicted values where it's got it wrong. Okay, and again we can arrive at this confusion matrix where you can see that in this particular case, actually we've got this one somewhat better here, okay, in terms of the result, slightly better than we had the other one. And here it's a little bit worse here. So previously, you remember it was only 2, now it's 23. So even here, I didn't get great answers. I would say it's kind of average in my estimation, even though we are using an AutoML, which you would think would go away, hopefully make some better decisions. It's really no better. Okay, awesome. Let's stop there, okay? So let me just finish off. And I know Matt's chomping at the bit to get some questions my way. All right, so what do we look at? We looked at how we could manage some loan data with SingleStore, okay? We can store that directly in the database system. We can easily build prediction models using standard machine learning techniques. But text generation, Shat and Lime, awesome. I really like them, but not so useful in this particular scenario, in my opinion. However, you may disagree, you might use it, and you might find it much more useful. The LangChain SQL agent, great in terms of natural language ability to ask these questions and get responses back. Not so good because I think it's still too opaque. Doesn't give me enough details about how it actually arrived at the decision versus those previous techniques we looked at, such as Shat and Lime, which allow us to drill down further and look at what are the things that are actually influencing the model and influencing the ultimate decision. There we go. So final cut there. Any sufficiently advanced technology is indistinguishable from magic, from one of my favorite authors, Arthur C. Clarke, okay? Wonderful quote. That's what it feels like, okay? Thank you very much, okay? And let me just go here as well. Keep that on the screen whilst Matt picks some questions. Hopefully we got some time there, Matt. I know it's almost the top of the hour. I did try to get through as fast as I could.
All good. You've done great. I know we've gotten a couple questions about like LLMs used. I know there was one earlier about, could I switch in a Spanish trained model or data set? And I know you've done a couple different webinars using different models and different approaches. So I wonder if you could just talk about that a little bit.
Yeah, absolutely. Great question. Yes, you can. Okay, so just because I happen to use OpenAI here in this case doesn't mean you have to. For this particular example, especially the LangChain part to work, yes, you will need an OpenAI key, but you could substitute something else. Okay, check to see what LangChain works with, and it works with a wide variety of tools and technologies. Okay, so if you have something else that you prefer to work with, go with that instead. Absolutely fine. And yes, this was in English. That's a great question in terms of asking it in another language. I know that OpenAI's technology for sort of voice recognition can work with multiple languages. I don't know about LangChain itself. That's something that I'll check into and look into. But that's a great question. Thank you very much for that.
Good stuff. I know we've gotten a lot of questions about Akmal's notebook link. It is not available yet in the gallery of our usual spaces, but it will be. You've gotten a lot of nice notes here, Akmal. Greg says you're a magician. Philip says another great session. So,
all right, great. Thank you. Matt, what I'll do is just to save time, I'll share the link with, and I apologize for the delay. It's simply, as I said during the webinar, I struggled because stuff changed, broke my code from before. And I was pulling, I'm already lost a lot of hair. I don't have much anyway, but I was pulling out even more hair, trying to fix it in time. Fortunately, things worked out eventually, but we'll get that to you as soon as we can. And you're very welcome to. So you've seen how to create the workspace spaces. You've seen how to import. Essentially, if you want to run the LangChain part, you just need the OpenAI key. You're welcome to customize that and change it if you wish, but the rest of the stuff will work absolutely fine. It's all self-contained.
Awesome. Thanks, Akmal. Let me announce the raffle winner. Quick note before I do that, though, reminder, the slide on your screen on Wednesday, just 2 days from now, we're going to be presenting this how to protect data in a thin-serve RAG pipeline. We'd love to see you there. I know there's a lot of folks that we get that say, this is really cool, this is awesome, magic, but I'm worried about data security. I'm worried about customer data, proprietary data, et cetera. Come join us on Wednesday. You can see a solution that handles that use case. All right, let's get to the announcement you've been waiting for. Today's raffle winner is Andre Stoyan, Director of Machine Learning at Zama in Paris. Congrats, Andre. You can either get your AirPods or the new Meta uh, Ray-Bans, the LLM smart glasses. So we'll talk to you and get a sense of which of those you prefer. If that's not you, don't give up. We're going to give out one more prize today to someone who has tried out Akmal's demo. So again, keep an eye on your email. You're going to get the link to that notebook. You're also going to get a link to the recording of this session. And we will announce one more winner before the end of today. Thank you so much to our audience. Thank you to Akmal for another amazing presentation and demo. And thanks. I hope we will see you all next time.
Bye-bye.
Bye-bye.